Assalamu alaikum. My name is Moaaz Ahmad, and in this video we will be discussing the lab 7 of DLD. This lab is all about Karnaugh maps, and our sir allowed us to select any circuit of our choice. So the circuit I selected is 2-bit comparator circuit. This circuit basically performs functions where inputs are either equal to one another, or one input is greater than the other, or the input is less than the other input. So this is the truth table of our circuit, and we have 4 inputs right here: A1, A0, B1 and B0, and there are 3 outputs G, E and L. And if I go to my next picture, and here are the K maps of this circuit, and right here we have our equations for all the 3 conditions, which are A is greater than B, A equal to B and A less than B. So in this circuit we were required to implement it in both Proteus and in Quartus. So if first I go to my Proteus circuit, and let me zoom in a little bit so that we can see it better. And now if I run my simulation in Proteus software, and we can see here that both of these numbers are equal to each other. That's why the D2 light is turned on. And but if I change the input to something else, say I change it to 1, and now you can see that since input 2, which is B, is greater than input 1, that's why D1 is now on instead of D2. But if I change the value of A input to something else, like I change this to 1, now we can see that since A is greater than B now, that's why D3 is on instead of D2 and D1. So that's it from this Proteus circuit. Now let's move on to the Quartus software, and in here I have already implemented the circuit in Quartus software, and we have 2 inputs and 3 outputs as we have discussed earlier. And now if I start analyzing this circuit right here and let it finish the analyzing procedure, now it has finished the analysis procedure and it was successful. So I will close this report from right here, and I will go to my new menu and select the university program VWF file, and I will hit OK. And if I right click here and select insert nodes, and here I select node finder and then list all the nodes that are available to us and add all of them and click OK, and these two M and N are our inputs, and A1, A2 and A3 are our outputs. Now I will go inside of my A input, and I will give the A0 a clock value of 100, and I will give A1 a clock value of 200. Now I will go to my B input, and I will give B0 a clock value of 200, and for B1 I will give the clock value of 400. And now I will run this simulation, and I will save this file and click save, and now I will just wait for it to finish the procedure. So our procedure has finished here, and we have our waveform in front of us. And now I will close my waveform editor from here, and I will go back to my Quartus software. So let me do this, and I will close this too, and I will open my Quartus software. I will right click here and select locate node, and in here I will select the RTL viewer, and I will wait for the loading process to complete. And it has completed, and we have our circuit in RTL view. So that's it from this video, and till next time, Khuda Hafiz.